Welcome. It's my pleasure to welcome you to this session on climate mobility projections, modeling. Um, it's a really interesting one. We'll be looking at different ways to model future climate mobility trends, the areas that are most at risk and where people might be moving. And we'll have two very different types of ways of going about this. As you know, the GCCM has been working with modeling in addition to on-the-ground field research from the inception. And we're very interested in seeing what are the approaches that are out there, how can different approaches perhaps be combined also to gain additional insight and maximize the value and the utility of these models. I'm very pleased to have colleagues from the Luxembourg Institute on Social and Economic Research, Mr. Michal Bozinski, joining us. And we've had a fruitful collaboration modeling climate mobility for our Greater Caribbean Climate Mobility Initiative. And Michal will talk today about the underlying model and the global projections and platform that he is working on. And we also have colleagues with us from the CIMA Research Foundation, Mr. Lauro Rossi, who will speak about their modeling of climate-related displacement and where the probabilities are highest for people to be displaced in the future. And he's joined by his colleague, Mr. Alvaro Rojas Ferreira from the United Nations University. So I'm very pleased to have all of you with us today. And before we get into the presentations of the models, I wanted to ask you both if you could share a little bit of background, like why do we do modeling? What was the motivation for developing these models? What are you hoping to achieve? And I'll bring this question first to Michal and then to Lauro and Alvaro to give us just a brief background to the presentations we're then about to hear. So, Michal, do you want to maybe kick us off?
Thank you so much, Sarah. Thank you so much for having us here at COP30. It's a great pleasure to be able to present you the Climate Change Migration and Economics model, in short, CLICME. It's a model that hopefully increases our knowledge about what are the potential consequences of climate change for the economic growth, development, and migration over the 21st century. So this is, for the moment, a model that is motivated by the fact that, well, we wanted to say something more about how climate affects global economy. So CLICME is a dashboard, is an online tool directed for, designed for policymakers and non-academic stakeholders to be able to see potential consequences of the future, on the future macroeconomic outcomes, individual well-being, and also how climate will influence climate-induced migration. And here in the model, within the model, we are talking about a specific type of climate migration. What I mean here is long-term, voluntary, permanent, and economic motives of migration. So it's very complementary to what colleagues are going to present in a minute. Now, when building the CLICME model, we had two important things in our mind. First of all, we wanted to have a very precise and state-of-the-art way of projecting climate migration, and those highest academic standards are reflected in the papers that we managed to publish with this model. But at the same time, we want to respond to the needs of non-academic actors, to the stakeholders, policymakers who are hopefully capable of using this type of data in their daily work, in their analysis. So the motivation for this research, for this model, is threefold. So, of course, we started with pure academic curiosity research questions. So we simply wanted to know what are the consequences of climate change for the future distribution of economic gains and losses, internal and international migration of people, and the implied measures of inequality and poverty. However, the innovative part of this was to use a specific methodology that incorporates three fundamental pillars on which our model is built. First of all, including multiple climatic factors that together give you the broad picture of how climate change affects all of those factors. Secondly, having a detailed geographical resolution of the model so that we have a very precise measure of how climate affects specific populations in specific places. And then the third thing, not the least important, probably the most important from the point of view of the policy making, is how different types of people are affected by those effects. And I mean here by different people, by socio-demographic characteristics, because we know that matters a lot. But then, 3 years ago, when we managed to publish the first version of the model, we were lucky enough to get into cooperation with GCCM on modeling climate migration, climate mobility in the Greater Caribbean region. And this was the turning point for our ClickMe project, because then we realized that academic excellence is nice, it's good to write nice papers, but what matters a lot is actually the societal impact. The fact that this data that we provide here can be useful for policymakers, for stakeholders, for people who are interested in general to talk about climate change and its impact on the economy and migration. That is why we designed and implemented a hopefully user-friendly open access dashboard that allows you to visualize all the data that our model is providing. Not only that, we also share all the knowledge on how the model is built, calibrated, what data we are using, and the case studies that are written up using our model. So in general, what I will show you just later on, you'll be able to see all the main variables of the model in the online dashboard, filter through them, search, immerse into the tool so that you can see how things work. That is why right now the key motivation for the ClickMe project is the value added through the non-academic scope. The fact that we can provide an easy to access data for policy, climate migration policy analysis, visualize the areas and populations under various climate hazards, display likely migration pathways at the global level and at the local level, and show the extent of climate damages. Therefore, what we provide is both a big picture for policymakers and an ability for them to go to really deep focuses, deep dives into how climate change affects growth and migration. Okay, thank you.
Thanks so much, Michal. Do you want to come here or speak from the...
Thank you very much. I will be brief, so I can pass my word also to Alvaro. No, I'm fine. So, about motivation. So we know that there will be more extreme events related to weather and climate. We know more or less where these events will take place, but we don't know yet, what is the impact in terms of displacement. So this is the first motivation. Try to translate, the climate forcing into something tangible, which in this case is impact in terms of displacement. So with this type of model, we have built, physical model of all the world, starting with, very local example and scaling up to reach, this global assessment. So with this model, we were able to differentiate area of the world where there will be a huge increase in displacement related to 4 different hazards: strong cyclone, strong winds from cyclones, coastal and riverine flood, and drought. So, and the scenario is not homogeneous. Every part of the world tells a different story, and with this model, we are trying to, let's say, untangle this this projection. So once the model is built for the present climate, we project it into the future, and depending on scenario, we'll have different results. I won't spoil the result now because it's part of my presentation. And the good thing that is those models are shared, and the results are shared in a platform. I'll leave you the word to Alvaro to complete this.
Yeah, thank you so much. Thanks, everyone. Can everyone hear me? I don't know if that side. Thanks so much for joining us today. Yeah, I think that question is, can I speak louder? Can you hear me better now? Thanks so much. I guess the question is interesting in itself, and what is the importance of modeling this type of situations. I think from the work that UNU does, we work directly with a lot of decision makers, and a question that we always get is dollars. People and decision makers, and that has a good reason for. We all are concerned about how much things will cost and how are we going to address those issues. So for us, it makes all of the sense in the world. However, these type of impacts are often less visible, and usually it's related to the numbers as well. So many decision makers can communicate things better and understand things better when you tell them there's a certain expectation for a migration caused due to climate change. I think it's no mystery for anybody here. We're having sudden guests now. I'm glad. This is raising interest. I think there is no surprise for people in the room that climate is not the only reason why people migrate, right? It's a complicated dynamic, and there are many factors in, as were discussed before and will be discussed later. But being able to tell them how climate is likely able to make this worse in certain situations is something that is valuable for a lot of colleagues that we work with. So for us, that was very important to do.
Sorry, we have only one functioning mic, so we're going to have to pass this. Thank you all for kind of giving a bit of background to this exercise. I think for us, the motivation for using modeling is really to get to this idea of we're looking at the future. We're trying to not only look at what is going on today, which obviously, you get stuck in what's the most urgent thing, what is pressing today, what needs to happen, but to get a perspective on these current dynamics and really start a conversation, as a policymaker with your constituencies about where do we want this journey to go, right? There are different possible futures. How do we take decisions today to shape the future we want? And to have that kind of conversation, modeling can be a helpful entry point because it gives you a perspective on what the future could look like. Not obviously certainty, but it just allows for this space of potential futures to open up. And I think that's a key value addition. So without further ado, I think we will hear from our colleagues a demonstration of their models and the platforms also that they have built to make it easy for users to interact with the models, to play with different factors. And I invite Michal to the podium again, and I'll give you the mic back.
Thank you so much. So let me take a couple of minutes to tell you about the model itself. Since, the model is pretty standard in terms of in the economic sciences, but it's totally not standard in non-economic sciences. So, all right. So, key elements of the model. So what we have here is what we call in economics a spatial general equilibrium model of the world economy. So what does it mean? It simply means that there are a couple of markets in the world that are co-integrated within the model, and they work together or they solve together to get the final result. And what are the markets that we include? It's production, so firms produce in one of three sectors, so it's either agriculture, industry, or services. We have individuals, so people in the model who reach their consumption decisions subject to their preferences, subject to prices of goods and services that are endogenous within the model, and subject to individual incomes. Now, incomes are the outcomes of the labor market equilibrium, so another market. There we have a situation in which people offer their skills to firms to work, subject to different heterogeneous distribution of productivity across space, and this is how we compute wages. All of this is then embedded in international trade networks, so we are capable of replicating, all the trade flows across all the country pairs in the world for the three sectors, and this is an important element. Now, What is probably the most important factor of the model, and the most important feature of the model, is the way that we treat geography. So we divide the world into countries, which are then divided into admin units, and then admin units are divided into millions of pixels. Small 5 by 5 kilometer areas of land that represent local economies, characterized by demographic, economic, and climatic factors. And this is a fundamental feature of our model because this allows us to control what is the overlap between the unequal distribution of population density. Shall we continue or what?
Yeah, let's just continue.
Yeah. So the most important feature of this very detailed geography is the way that we can control the unequal overlap between demographic distribution of people, the distribution of economic activity, and distribution of climate shocks across space at a very detailed level. All right, so the climate shocks that we include in the model are 5 main categories. So we have high temperatures that affect worker productivity, we have heterogeneous effects across sectors, there is sea level rise that permanently floods coastal zones, and it causes 2 effects. First of all, it permanently destroys capital productivity. Okay, it works, fantastic. So it permanently destroys capital, so reduces productivity, this is one effect. And the second effect is that it displaces people whose homes are flooded. So those guys who reside in the flooded areas. The third element we have in the model are disasters and their impact on amenities through changing in expected losses caused by droughts, floods, cyclones, and heat waves. The fourth thing, which is very specific, and it was designed explicitly for the Greater Caribbean model, for the GCCM, are oceanic changes. The way that coral reef bleaching affects tourism sector in the coastal areas of all the countries in the world, especially relevant in the Caribbean region and the Pacific region. And the final thing that we have in the model are agricultural yields, agricultural productivity, for land productivity, that is crop yields. But the main focus of the model are people. That is individuals who are classified into one of 24 adult groups. So we have 3 age groups by 20 years, multiplied by 2 gender groups, multiplied by 4 education groups. And why it matters? Well, because we know very well that all those socio-demographics, they matter for economic decisions, for reaching economic decisions. And especially when you look at migration decisions, migration is very biased towards young people, towards men, towards those highly educated with a famous brain drain effect. So all of those things have to be controlled in a reasonable way when talking about climate migration. So those individuals within our model, they reach their consumption decisions by maximizing utility. So if it happens that the pixel in which a person maximizes their utility is a different pixel than the person was born in, then we say that the person is moving, migrating to another pixel. And qualitatively speaking, we have 3 types of migration here: international migration across country borders, national migration within countries across those administrative units, and then local migration within admin units and across pixels. But note that all of those migration flows are origin times destination specific, which means that, for example, for international migration, we have the whole 200 by 200 countries matrix. But wait, that's not all, because additionally to that, those matrices are also socio-demographic type specific. So you have different metrics for young educated women and a different metrics for old non-educated men, and so on. All right? So this is a very large set of data that we are generating actually. All right, so that's enough about the model. If you are interested in more details about how the model is built, what data we use, I'm happy to talk about this. Now, let's move to the dashboard. The dashboard, that is a tool that allows you to immerse yourself into the data that we generate into the model results. So what the dashboard offers you is to search through different macroeconomic variables that are generated by the model. It includes population, migration, poverty, and other economic variables. You can search through different climate scenarios, which are in line with the IPCC projections. This includes the RCP scenarios and the SSP scenarios, which are linked to this. And 4 periods in the future, model is designed by 20 years. It is how it is. We are talking about long-term migration. Then, of course, you can choose geographies, continents, countries, admin units, and go down even to local pixels. Then you can filter across different socio-demographic groups, as the way I mentioned. And the last thing which is still not available for the dashboard because the final version of the dashboard will be available in mid-2026, is to be able to filter across climate hazards. So you'll be able to see what are the climate migrants generated by a specific hazard. For example, sea level rise only. All right? Now, it all looks great, it all looks fine, but it's still modeling. So I have to say that there are some caveats behind all the results that are published there. Since we are talking about modeling, this is only a model, which means that, well, by no means we are trying to predict or forecast the future with the data that you will see in the dashboard. These are only projections that are as good as the data that we are using, and those data are pretty good. But we necessarily do extrapolations of the past data to the future, necessarily. So if the future is different from the present or the past, which is likely the case, well, of course, our projections lose precision, right? You have to, when using those types of data, you have to take this into consideration. But in general, using models is connected with uncertainty, with basing on assumptions, with the fact that not everything is clear-cut and not everything is exactly how it could be in the future. All right, so to summarize, the future for the ClickMe dashboard is as given here. So in mid-2026, we will publish the final version of the dashboard that will allow you to filter through climate hazards, will allow you to download the data in the raster file, so the maps, or in the aggregated way through tables, aggregated in the country level, for example. We'll have some quality of life improvements of the dashboard as well, colors, things like this, tutorials. But in general, of course, what is important is that the dashboard is a tool for policymakers and other stakeholders, non-academic stakeholders. So we are very much looking forward to your suggestions and feedback. What you would like to include in this type of dashboard? What could help your work in terms of the data access, in terms of what we provide there? So I'm happy to discuss this, and I'm happy to talk about the future of the dashboard as well. So please, you can already check yourself the dashboard at clickme.lizer.lu. But importantly, this dashboard is available only on PCs and laptops. So it will never be capable of working on a mobile device, for example. For now, it's 1 terabyte of data. In the full version, it will be 15 terabytes. So it's not going to be possible whatsoever. This is the dashboard. Okay, so there's a landing page. Then you have a link to the dashboard itself, and this is the dashboard. It's a fully flexible, immersive thing that you can check. And the first thing you should select in the dashboard are the variables. Here in the top left, we have a couple of groups of variables, including migration, economic variables, and that includes GDP, per capita, changes in prices, and so on. Let's stick to migration for the moment, and the main aggregate for migration is net migration per pixel. All right. So what is the change in the number of people due to climate migration only? Because we are identifying within our approach only climate migrants, and this is super important. So here, what you have in the dashboard are only the impacts of climate. Now, the second thing that you probably need to select is the scenario and the time period in the future. So for the moment, we are stuck with RCP 7.0. in year 2050. The third thing, and probably the most interesting thing, is to go through the geographies. So you can select first the continent, then you can select the country, you can select the admin unit and go down to individual pixels and see what is happening. Of course, the colors tell you what are the intensities of the variable that we are looking at. Here, once again, net migration. Red pixels means net negative migration, so less people in the pixel. Green ones, positive net migration. And then the last thing is the right-hand side panel. The first thing here is you have an aggregate for the particular selection that you do. For example, here for the country of Tanzania, we are reporting minus 80,000 net climate migrants in a particular scenario in a particular year. But here below is what makes the data, the model, useful for policymakers. That is the selection across socio-demographic groups. So you are free to select education, age, gender groups, whatever you like, and to see how this changes. Of course, the Wi-Fi is not super fast. At home, believe me, it will go way faster than here. So that you can check different scenarios, you can check what is happening in different types of situations. All right, so this is what the dashboard is. I hope that it's intuitive and helpful for navigate through this. The last thing I wanted to say is the important aspect that is actually missing from the big picture. That is, well, climate migration is important, but what really is problematic from the point of view of policymaking is actually climate immobility. The fact that people are not moving from the areas which are subject to climate hazards because of different factors. And this generates poverty, climate-induced poverty, which you can see here. The red dots show you the places where people are just moving into poverty. This is RCP 7.0 year 2090. And this is probably something that policymakers should look into, not only when talking also about climate mobility and climate migration. Thank you.
Sorry, I was so smitten with the map. No. Thank you, Michal. We'll open it up for questions after the next presentation, so hold your questions. I would like to ask our colleagues Alvaro and Lauro, I don't know who wants to go first, Lauro, to introduce the internal displacement model.
There should be to go.
Well, while you're fixing, I can just talk. No problem. So, yes, I'm going to present this global effort that is the result of a collaboration of 5 institutions. So the United Nations University Institute for Environment and Human Security, represented here by Alvaro, Children Research Foundation, that is my organization, ATH Zurich, and Earth Observatory of Singapore, and of course the Internal Displacement Monitoring Center, IDMC. So we already mentioned the motivation, right? To try to, in summary, it was, try to quantify the numbers and then displacement. So the idea that we have here is to use the CAT modeling approach to displacement. So really try to quantify the impact in terms of displacement of these 4 hazards that I mentioned before. That was possible because of 2 different platforms, different but very, very, let's say, similar in terms of concept. One is Climate and the other is ProRazor. There's an open source probabilistic climate risk modeling platform. And you have here a reference paper where all the methodology and results are published. So the basic idea here is to look at physical vulnerability. That means the vulnerability of structure. So basically residential buildings where those structures are not able to provide their function. People have to displace. And this is used for strong winds and coastal flooding. While for floods, we went a step beyond, and we consider also the loss of livelihood. The physical vulnerability is still, the pivot that we used here, because, we were thinking if in the workplaces is not more accessible, just thinking of the agricultural field, this could be a cause of displacement. While, I mean, for drought, we use a totally different approach. We went to systemic vulnerabilities, and we tried to include 5 different dimensions of this vulnerability: social, environmental, economic, demographic, and political. Let's go deep a little bit, dive deep into the flood modeling. So here is the scheme that we have introduced. We try to summarize here the idea. So people for us need to move if they no longer have home available, if they no longer have a job, or if essential services are no longer available in their area. And of course, you know, the causal relationship becomes unclear and direct when you move to, you know, this essential part. I mean, this methodology is published, and it was, as I said before, applied at very, very local scale where we have data at building level. So we have the possibility to calibrate and to, you know, validate in certain, I mean, for at least a local scale in 2 islands, Fiji and Vanuatu, this methodology. And this is the risk modeling framework approach, you know, the CAT modeling, what you call the catastrophe modeling approach. So we have global climate circulation model that force the hydrological modeling, the hydraulic modeling in cascade into, you know, detailed hazard map are produced. And with that, we produce thousands and thousands of events. So not just, you know, the usual observed event, but with some technique, we try to we made some perturbation of the events that try to predict also the unseen event in climate, in present climate, and in future climate. So this is the hazard part, and then we apply this to detect and compute the impact modeling with the exposure model, vulnerability, the physical vulnerability, and the vulnerability to displacement. And what we had here as a result is the 2 metrics that are normally used in CAT modeling, that are average annual displacement and probable maximum displacement. So here is more or less what we did. So whenever there is a level of damage over a certain threshold, this could be, I mean, either a residential building or workplace. I mean, this place is not anymore able to fulfill their function, the residential function or the job. So here we have displacement because they lose their job, people lose their job, or just because, I mean, they lose their home. And here, you know, it seems quite straightforward, but when you put all the parameters in the computation, it's not. For example, we have to avoid double counting because people can at the same time lose job and residential buildings. So here there is all the framework that you use in order to avoid double counting. Basically, with the correct criteria of proximity, we estimate where people go to sleep at night, where workers go to sleep at night. Then we have 2 different factors. One is that, of course, not all workers decide to leave, and there is so this percentage of workers that decide not to leave even if they lose their job. But on the other hand, there is another compensating factor, but when the breadwinner leaves, all the family follow. So it's another parameter that we took into account. And these are the results, very, let's say, comprehensive, and sum up all the impacts for all the 4 hazards that we consider. The idea is as to, you know, not even at country level, but we go at national level. So administrative one, we can detect what are the area of the world where these climate hazard have most impact. And those, I mean, the last line there is the projection. In the future, we are going, depending on the scenario, we have modeled an optimistic scenario and a pessimistic scenario. So depending on this scenario, the global figure will double or triple almost. Another, I mean, just the last slide. Since we have done with this, with this approach that we consider also loss of livelihood, we are able to disaggregate. This is just an example for Ethiopia, but here we wanted to show the type of result that we are going to obtain by this model, that are, the cause of displacement can be mapped at national level, but also subnational level, and saying what is, people move because they lose their house, or, the employment, and which sector. So policymaker can actually address, the sector that is more affected in terms of displacement. I'll stop here. Leave the floor to Alvaro.
Thank you, Laura. Okay. I'm gonna move now, and I'm just gonna show you how the current version of the model. This is the platform that was developed, that is based on IDMC, the International Displacement Modeling Center. And this platform was designed as a dashboard that is designed for you to be able to navigate through these results. It aims at doing something in a way that is friendly, and you can have access to both the data, but some stats or some analytics that you can already use in order to make this. I think usually when I start talking about modeling results, I try to remind people that projections are not meant to provide you with exact numbers, especially when they go to the future and when there are such complex phenomena, right? So you're gonna see here a lot of numbers. So for example, we expect under current scenarios, on average, 15 million people is internally displaced due to riverine floods. That means that there needs to be some infrastructure for that order of magnitude, but these 520, so 15,396,520 is not the exact numbers of beds or something that is needed to be there. So how we analyze data and how we communicate data is also very important. Something that this platform allows us to see is how these trends change. So here, for example, we have these 3 points. And we can see something that already Lauro was alluding to, is how under different climate scenarios, this is gonna look by 2100. Now, this takes a lot of assumptions, right? So in some areas where, for example, there is conflict or they're having certain issues, this change is gonna define also the internal displacements, because nothing of this works in isolation. However, it gives you an idea if things remain the way they are now, how things would change by 2100 in terms of this migration and these needs. So again, what we were discussing at the beginning, this just opens for conversations for us to understand what is the importance of this in different contexts. I'm gonna try not to take too long so we can also hear a bit from the audience and address some of these questions. But this is the map that we would have there for riverine flood. And this shows how these numbers of migrants change within different countries. We saw from the presentation before and from others that within the countries themselves, there are a lot of dynamics, and not all migrations are defined by geographical borders. But this gives you an idea of how this works. The map here shows in the darkest blue over 100,000 people, migrants, internal migrants expected per year due to riverine floods. Again, it's important to look at this with certain nuance. I'm gonna start with, for example, my country. I come from Colombia. And you will see how here there's appeared 3 values. It's the current expected number of migrants, the one under an optimistic and the one under a pessimistic scenario. This number for Colombia is around 113,000 people per year. Now, if we move to Brazil, our gracious host of the year, this number includes to 447,000. In Colombia, we are around 50 million people. In Brazil, there are over 100 million people. Over 200 million people. So even though the number is 4 times as high, consider that the population is also 4 times that high. It's also a relevant factor. We will see a different dynamic, for example, in a country like Russia, in which the population is, if I'm not mistaken, twice as high, so 100 million people. But the expected numbers of migrants is similar to the one in Colombia. So we can see that even though the numbers are still high there, respective to their population, that is different. So these type of analyses are important. These type of analyses are relevant for decision making at a global level. Right now, this year, for example, we're discussing the indicators for the global goal on adaptation. And an important topic here is related to migration itself, right? So how are we gonna adapt in order to do that. So this type of factors are meaningful and allows for some sort of decision making. Something else that our platform or dashboard presents, so I hope this shows, it shows country by country insight. So for example, if we're gonna go, let's stick to Brazil. We look for, I guess it's lower. Sorry about that. So we will see different types of values. So here again, sticking to flood, we see how this number of 447,000 is distributed among internal different regions. And we can see that this is more relevant, for example, in areas like the Amazon, when we are now, compared to the south of the country. Brazil is a huge country itself. We will also get the estimations on this upper side on how this changes under different scenarios for the year 2100. But also importantly, it shows us in certain return periods how this is gonna change. So the information that we get here is an annual expected impact. For those of you who are very familiar with numbers, average usually don't give us all the information we need to have, right? So a good example, I don't know if you think in school children and you take all of them and get an average height, it's likely that none of the children actually has the average height. There are gonna be a huge distribution that you need to take into consideration. What we present here is some of the extreme cases, so people are also aware that even if in this year the flood doesn't give you a specific number, this could go up to, under certain return periods, to very, very high numbers. So in the case of Brazil, it would increase from the average that is from 147,000 per year to 912,000 in the return period of 50 years and to 977 in 100. The return period is often misunderstood. Often people think that it's 100 return periods mean that the flood only happens once every 100 years. This is a probability. It means that every year we have a probability of having 100. It's just lower than one that is more frequent. I would like to move maybe to another hazard just to give us an example. We now know that the host of COP32 will be Ethiopia. So maybe we can look into them. Sorry, here. And we go for Ethiopia and we look into droughts. Here again, similar information. We find a total number, 393,000 people related to migration, internal migration related to drought. And we can see how different regions have different rates of migration. We can see Afar on the north being significantly lower to all of the neighbors, but it also related again to the average population. We do that exam for extreme cases. This one, for example, we see how drastic is the change of a regular annual drought or expected compared to the more extreme scenarios. So 50 and 100-year scenarios are much more impactful. For floods, usually return periods of 1,000 are those that are the most, the strongest. I'm gonna end up with one example on the Philippines for tropical cyclones. Just for you to see, to give an overview of the types of hazards that are available in the dashboards. I think the Philippines is after P. Here. And as you know, the Philippines and Southeast Asia is unfortunately very exposed to tropical cyclone. Not long ago, last week already, there were all of the alarms related to those impacts. And we can see the Philippines actually has very high numbers for the 4 hazards that we're studying in the platform, unfortunately. But it provides us with very similar information. It tells us in the current scenario how many people we would expect to sometimes. I guess it's taking a minute loading, but it would show you the maps of the Philippines, how it is distributed in different regions, and how more extreme events differ from the expected annual impacts there. I think I'm gonna close with just maybe forward-looking comments on how we expect things to evolve with the platform. So I guess 3 conclusions that we have here is that numbers and trends matter. This information is useful for decision making, is illustrative. It has limitations, but it can support planning. It can support forward-looking approaches like the one we were discussing before. Evidence-based policy and planning is useful. It's not the same to be discussing about something that we're not very aware of, or we cannot have an estimation at least of how this is currently is and will be in the future. So these types of tools are useful for decision making. And this is, I guess, the most important for me, my favorite at least, open source modeling. All of these platforms are open source, which means two things. One of them is that they can be verified. You can go into it and see what happened. If you have better local data, if you have other information that maybe you cannot make public, you can use it to replicate it. But the other open source is that it's not all in the hands of one person, right? So everybody or with certain skill set would be able to use these tools in the future. What we think for the future, so we were yesterday in a session related to anticipatory action. And this is something that we think this type of modeling can be very relevant. So it's important to talk about the far future, but also tools like this could be adjusted for the near future. So if we can already have a footprint, for example, of how a flood would look like, which regions would be affected, what are the vulnerable groups there, we can have an early estimation of how that will translate into displacement, internal displacement. So this is something that we're currently working on. Again, there are several uncertainties and others, but Climata, which is one of the models that was used, this is already being calibrated to respond for those for other types of assets, economics and other. So it could provide a good view there. And finally, cost of displacement. We all know there are certain stakeholders that only care about the USD or are mostly motivated by dollars or monetary value. Displacement is not for free. It has high costs. Responding to that has costs. So being able to estimate some costs, even if they don't cover everything, might be also a useful tool to communicate these outcomes. Thank you so much. And
thank you. Really interesting.